Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to look at part 1 of Exponents for Mathematics Grade 10, and that is Basics and Laws. For part 2, we're going to focus on solving exponential equations. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on part 2 of this video and any new videos we upload in the future. Also, if you'd like me to make a video specifically for you, focusing on any topic of your choice, for any grade that you choose, please let me know down in the comments and I'll make that video for you. Yes, I will, and send a shout out to you in the video. Now let's start. When we talk about exponents, we're basically talking about numbers that can be expressed in this format. For example, 2 to the power of 3, which means 2 multiplied by itself 3 times. In other words, 2 times 2 times 2, and that is equal to 8. If you don't believe me, take a calculator and punch these numbers, 2 to the power of 3, and you will get 8. The number at the bottom is what we call the base, and the number at the top is what we call the index or exponent. One index, many indices; one exponent, many exponents. That's why in some textbooks, this whole chapter is called the chapter of indices. It means exactly the same thing. And this whole thing, which is the base together with its exponent or index, is what we call a power. Very important definition to keep in mind. This whole thing is equal to 8, meaning that 8 as a number can be also expressed as 2 to the power of 3. Now, before we look at some of the laws of exponents, let's look at some of the identities of exponents that we use often to calculate. The first one is that when you have a to the power of n, that simply means a multiplied by itself n times. Also, any number raised to the power of 0 is equals to 1, meaning that you can write 1,000,000 to the power of 0, and that will be equals to 1. You can write 1 as anything to the power of 0. Also, if you have an exponent or a power with a negative exponent, that can be made positive by turning that as 1 over a to the power of positive n, for example, when you started with a to the power of negative n. Similarly, if you have 1 over a to the power of negative n, you can simply take this to the top and it becomes a positive. So that is 1 a to the power of positive n in this case. Now let's look at some laws of exponents. The first law is that when you multiply powers of the same base, you add the exponents. When you divide powers of the same base, you subtract the exponent, but be very careful how you do that subtraction. You must subtract the power of the index of the power at the bottom from the index of the power at the top. Not switch them around. It's not n minus n, it's m minus n. Very important, keep that in mind. Now, if you have a product, which is a result that you get from multiplying 2 or more numbers together, if you have a product raised to the power of n, you can break them up and have those factors, a and b, for example, in this case, each individually raised to the power of n and multiplied together. The powers multiplied together. Also, if you have a over b all raised to the power of n, that is simply a to the power of n over b to the power of n. Also, another one that's important, if you already have a power raised to another power, all you do is simply multiply the exponents together over the same base. Notice that your a and b can never be 0. It must be either positive or negative, but it can never be 0. Because remember, 0 raised to any power of anything is just 0. Alright, and your exponents must be elements of real numbers. That includes negative numbers, 0, plus, minus. It includes fractions as well. Any number that you can find in your calculator can be an exponent. Now let's look at some examples on how we simplify depending on what it looks like. Let's say you've got a question like this. This is how you attempt it. You go equals to. Now we apply the laws of exponents to help us simplify this. So we'll leave that as it was. Notice that you've got 4 and 16. Both are powers of 2 and must be written as powers of 2. And this is how we do that. We go 2 to the power of 2, that is 4, or raised to the power of n, and that 2 can also be raised to the power of 1 or written as 2 to the power of 1, which means exactly the same thing. Now 16 can be written as 2 to the power of 4, so let's write it as that and raise it all to the power of n. Now remember the laws of exponents we just looked at? Exactly. Now that you've got this power raised to another power, remember you just multiply the exponents, and that is exactly what we're going to do. So that is 2 to the power of 2n times 2 to the power of 2 times n, that is 2n, times 2 to the power of 1 over 2 to the power of 4 times n, that is 4n. Because you've got a power raised to another power, you simply multiply the exponents together. That is equals to, now we've got powers of the same base multiplied together. What we do, we add the exponent. So that is 2 to the power of 2n plus 2n plus 1 all over 2 to the power of 4n. Now let's add like terms together at the top. 2 goats plus 2 goats, that is 4 goats. So 2n plus 2n, that is 4n plus 1 all over 2 to the power of 4n. And when you have powers of the same base divided together, like in this law, for example, you've got powers of the same base divided together, you subtract the exponents like that. Remember the order. You must first write the exponent of the 1 at the top, and then subtract the 1 at the bottom. So that is 4n plus 1 minus 4n, which is equals to, all right, now let's add this together. All right, 4n minus 4n, that's 0. Then you're left with 2 to the power of 1 there. So you're left with 2 to the power of 1, which is also simply equals to 2. And that is your answer there. That's how you solve that question there. Next question. You have powers with different bases, that some are multiples, some are factors or multiples of other, some are powers. But this is how you do it. You go 5 to the power of 2x minus 1. There is no way you can reduce that 5 to any other. Now 9 can be expressed as 3 to the power of 2. So we do that all over. 15 can be expressed as a product of 5 and 3. Remember, make sure that you leave your bases as the simplest primary numbers you can find. And now we've got 5 to the power of 2x minus 1 at the top times 3 to the power of, you've got a power raised to another power, so you multiply the exponents together, and that gives us 2x minus 4 all over. Now you've got a product raised to another power. That means you break up the factors together and apart, and then raise them each to the power. So that is 5 to the power of 2x minus 3 times 3 to the power of 2x minus 3 as well. And that is equals to 5 to the power of, notice that you've got powers divided together of the same base. So you've got your 5 there, powers of 3 there. Now you remember, you subtract. So that is 2x minus, so that is 5 to the 2x minus 1 minus the power of the exponent of the power at the bottom, which is 2x minus 3. We're focusing on the 5s now. Multiplied by, very important, not divided by, but multiplied by 2x minus 4 minus 2x minus 3. All right, that is equals to 5. So now let's deal with the 5s. Now 2x minus 2x is 0. And then we are left with over here -1 minus -3. That is equals to -1 plus 3. So 3 minus 1, 3 minus 1, that gives us 2. So your 5 is left to the power of 2. Then times 3 to the power of 2x minus 2x, that is 0. Then you're left with -4 minus -3. Minus -3, that is the same as -4 plus 3. So -4 plus 3, that's -1. So you're left with -1 over there. That is equals to 5 to the power of 2 over, you take the 3 to the bottom to make it 3 to the power of +1, which then gives us 5 squared is 25, 5 to the power of 2 over 3. Can leave it as this, or you can leave it as a mixed number. 3 goes into 25 8 times, use the 3 times table, and leaves 1 over 3. Can leave it in any format you prefer or your teacher prefers. This and that is exactly the same thing. Next question. When you have an expression like this, notice that you've got a minus separating these two terms, another minus at the bottom separating the two terms. Be very careful with questions like this. You will need to bring back your knowledge of factorization into place. I made a video on that for grade 10. Please go back to that and watch that video so that you know how to do factorize. So what the first thing you do is you break this up into its powers, different powers. So you go separate powers. So you go minus 2 to the power of t minus 2 is 2 to the power of t times 2 to the power of -2 over 3 times 2 to the power of t minus 2 to the power of t, which is equals to, now I want you to notice something. We've got a common factor here, 2 to the power of t. Now that is equals to, so you take that out, 2 to the power of t minus 1 minus 2 to the power of -2 all over 2 to the power of t, that's another common factor at the bottom, in bracket 3 minus 1, which is equals to, notice that the 2 to the power of t's cancel out and you're left with 1 minus 2 to the power of -2 all over 3 minus 1. 3 minus 1 is equals to 2. 1 minus 2 to the power of -2, that is 1, minus 1 over 2 to the power of 2. Take that 2 to the bottom so it becomes positive. 3 minus 1 is 2. And that gives us 1 minus 1 over 2 squared, that is 1 over 4. 2 squared is 4, all over 2. Now you add the fraction. How do you add the fraction? Side note, 1 minus 1 over 4, that is equals to, your LCD is 4, LCD is 4, 4 is your LCD, so you have everything as your LCD, that's 4 minus 1. If you don't know how to add your fractions, I'm going to do a special video on this one so that you remember, so that it leaves you with 4 minus 1 is 3 over 4. So that is 3 over 4. That is equals to 3 over 4 all over 2 can also be written as 2 over 1. You will see why. Now all you do to divide these two fractions together is you multiply by the reciprocal. So you flip the 2 over 1 at the bottom upside down, and it becomes 1 over 2. That leaves you with the answer of 3 times 1 over 4 times 2. That is 3 over 8. And that is your answer there. Next question. You have an example like this. Notice that 9 is the square of 3. So 9 to the power of x leaves you with this situation. 9 to the power of x is equals to 3 to the power of 2, or raised to the power of x, which is 3 to the power of 2x, which is the square of 3 to the power of x. So immediately you write your 9 as 3 to the power of 2 so that you can see that square there. You will see exactly what we get at the end of the day. And so that is equals to 3 to the power of 2x minus 1 over 3 to the power of x plus 1. Now you use your knowledge of factorizing the difference of two squares, and that becomes, you have two brackets, and in the first one you put the square root, which is 3 to the power of x, and in the second terms you put the square root of the next term, which is 1 and 1. And then all you do is you have plus and minus, just like you would when factorizing any square or binomial, or difference of the difference of two squares. So that is 3x plus 1. Now notice that the 3x plus 1 at the bottom cancels with the 3 to the power of x plus 1 at the top, and you are left with 3 to the power of x minus 1, and that is your answer there. Last question. Similar story. 16 to the power of x. 16 is a square of 4, and 144 is a square of 12. So we have another square of binomial, or let's say the difference of two squares situation, that is equals to 4 to the power of 2 all to the power of x minus 12 to the power of 2 all to the power of b, all over 4 to the power of x minus 12 to the power of b. All right. Now that is equals to 4 to the power of 2x minus 12 to the power of 2b over 4 to the power of x minus 12 to the power of b. And that is equal to, you factorize the difference of two squares. So that is 4 to the power of x in the first terms of each bracket, and then 12b in the second term of each bracket. 12b, and then you have your plus and your minus all over 4 to the power of x minus 12 to the power of b. The 4 to the power of x minus 12 to the power of b cancels with the 1 at the top, and you are left with 4 to the power of x plus 12 to the power of b. And that is your answer. We've come to the end of the video. Thank you for watching, and goodbye.